So today I'm gonna go through the checklist of the second activity. First, I'm gonna write my name. That's done. Then note the expected resistances of the 3 different resistors used in the video from their color codes. So that's my resistors. The first one is orange, black. Second one is red, and black. And the third one is yellow, purple, and black. Yellow, violet, sorry, and black. So the color code for orange is 3. So the expected resistance for the first one will be 33 ohms. And then red, the color code of red is 2. So the expected resistance of the second one is going to be 22 ohms. And for the third one, yellow is 4, violet is 7, black is 0. So the expected resistance for the third one is 47 ohms. Now we're gonna use the, here is done. Now we're gonna use the multimeter to measure the resistance. So next is measure the resistance of the 3 different value resistors using the lab multimeter. So here's the multimeter. I have my banana plugs. I'm gonna put them in here. Black one into black one, red one into red one. And now I'm gonna measure the resistance of each resistor individually. So I'm gonna plug my positive wire across the 33 ohm resistor. So here, and I'm gonna turn my multimeter on and put the ohms. So for the first one, I get 32.78 and expected was 33. So now for the second one, for the 22 ohm resistor, we're gonna measure it now as well. And it shows 21.9 ohms. And it was expected to be 22. And for the third one, here, and it shows 47.12, and it was expected to be 47. Here, that's my third step done. The next part is draw a circuit schematic showing a DC voltage supply connected across, and choose a supply voltage between 6 and 9 volts. So I'm gonna draw my schematic here. That's the DC supply sign. So the schematic goes like that. That's the first resistance. That's the second resistor. And that's the third resistor. So as you can see, that one is my 33 ohm resistor. that one is 22 ohm resistor, and that one is 47 ohm resistor. And I'm gonna choose 7 volts to supply my circuit. And that's the 4th part done. So the 5th part is to calculate the current that will flow through the resistors. So for that, I need to find my total resistance first. So I'm gonna add all my resistor values. So our total is equals to 33 plus 22 plus 47, which is gonna be equal to 102 ohms. And now I can find my current by the formula. So the formula for current is V over R, voltage over resistance. Now we know our voltage is 7 and we know our resistance is 102. Now we can find the current. So it's going to be 7 over 102 ohms, which is equals to 0.0686 amps, or which is also equals to 68.6 milliamps. Yeah, so that's the 5th part done. Now the 6th part is to calculate the expected voltage across each resistor using Ohm's law. We know the current now, so we can find the voltage of each resistor by using the formula V equals I by R. Voltage equals current by resistance. So it's going to be the 33 ohm resistor is going to be equal to 0.0686 multiplied by 33, which is equals to 2.2638 voltage. Then the 22 resistor ohm resistor going to be equal to 1.5092, and the 47 ohm resistor is going to be equal to 3.2242 voltage. So that's the 6th part done. So next part is to demonstrate coarse and fine-tune voltage control of this DC supply. Here is my DC supply. I'm gonna turn it on. That's my coarse, that's my fine-tune. And now I'm gonna set up the voltage value that I've chosen before, which is 7 volts. So I'm gonna use my coarse, and to put the exact number I'm gonna use my fine tune. So here 7 voltage, and that's my step 7 done. Now the next step is to demonstrate how to set the maximum current. So we calculated the current earlier and we got 68.6 milliamps. So now I'm gonna put my maximum current. I think 120 milliamps is going to be enough. And now I'm gonna use my banana plugs. Plug my black one to black, red one to red. And Now I'm gonna put the wires across my resistors. So that's my red wire here, and my black one goes here. So now I'm gonna turn it on and show what's gonna happen when you set the maximum current. So the current drops, as you can see, it's 67 milliamps, close enough to what we got before, 68.6 milliamps. And yeah, that's it. That's the heat part done. Connect the DC supply across the circuit with the 3 resistors in series. Done. Show the current flowing on the bench supply is displayed when the on-off button is pressed in. Done. As you can see here, it's pressed in. Next part is measure the voltage across each resistor using the lab multimeter. So I'm gonna use my multimeter. I'm gonna connect my negative and positive wire to my 33 ohm resistor. Here is the positive wire. As you can see, the current is flowing. So now I'm gonna turn on my multimeter and hit the voltage button, and as you can see, we got 2.2532 volts, and the expected was 2.2638 volts. So now I'm gonna measure my next resistor. So I'm gonna connect my negative wire to a 22 ohm resistor. And now, as you can see on the multimeter, it shows 1.5060 volts, and before we got 1.5092 volts. And now I'm gonna connect the positive wire to my 47 ohm resistor. And as you can see on the multimeter, it shows 3.2238 volts. And before we got 3.2242 volts, which is close enough. Now that's the part 11 done. Measure the voltage across each resistor using the lab multimeter. The next part is show the effect of setting the current limit to half the expected current calculated before on the voltage between the output terminals. So here I'm gonna, on my DC supply, I'm gonna put the half of the current that was expected, which is 68.6 milliamps. So I'm gonna set it up to 34 milliamps, and now I'm gonna press the button, and I'm gonna turn on my DC supply. And what's gonna happen is the milliamps is not going, the current is not going to be 68.6 milliamps. What's gonna happen is the volts is gonna drop. So let's see, I'm gonna press the button, and as you can see, my volts figure is dropping to 3.33 volts. And yeah, that's it. That's my step 12 done. Show the effect of setting the current limit. and checklist shown and updated during the video done as well. Thank you.